So two of the crew members on board the International Space Station right now, Scott Kelly and Mikhail Kornienko, digging in to spend almost an entire year in orbit. And they're going to be doing a lot of studies that are going to be tracking how the body adapts to even longer times in microgravity. Now, I have with me one of the principal investigators of one of those studies, Dr. Tina Holden, who's the PI for the fine motor skills study. First off, thank you so much for joining me today, Doctor. And first off, give me just a real general overview. What is it that you guys are looking for while they're in space, that microgravity can do to the body while they're up there?
Well, we know from the spaceflight experience that we have to date that extended weightlessness tends to decondition the body, and that's why it's so important for crew to do exercise on board. What we don't really have a good handle on is what are the effects of extended microgravity on fine motor skills. We don't really have a complete data set in that area, and so the results are kind of inconclusive at this point.
Okay, and when you talk fine motor skills, what falls into that category?
Well, it's important to note that this study is not a medical study. It is a space human factors engineering study.
Okay.
And what that means is that we're very focused on the effects of long-duration microgravity on task performance, specifically fine motor task performance, the type that's required to interact with computer-based devices like tablet computers with touchscreens.
So a lot of dexterous activities, things like that, just really, working with their hands a lot, that kind of falls into the fine motor.
Exactly, and particularly human-computer interaction. So your ability to interact with the user interface, pointing, clicking, dragging targets on the screen.
Okay, and so we've had crews flying to the International Space Station for years now, and I mean, what are some of the things that we've seen with their, fine motor skills in that time so far?
We know for the most part crews have been very successful in completing their mission objectives, and we really haven't seen problems, but there haven't been a lot of studies looking at the fine details of how long tasks are taking to perform. There have been a few studies that have shown tasks take longer in microgravity than on the ground, but really none of the studies completed have looked at the types of tests that we're including in this investigation, those specifically targeted at working with computer-based devices.
Okay, walk me through some of the tests that you guys are going to be doing. How are you collecting, the data for this study?
Okay, so we're going to have crew members complete 4 different types of tasks. These have been very specifically chosen because they include the component actions of interacting with a computer-based device. They are a pointing task, a dragging task, a shape tracing task, and a pinch rotate task. And these will all be done on an iPad computer, and this is one of the first times that an iPad has been used on ISS for science. So it's kind of exciting.
Okay, yeah, I mean, they use them for a lot of just reading manuals and stuff like that. And this is important because, so much more and more things are computerized and miniaturized. So really tracking that fine motor skill could be important. And we need to see if there is anything that could inhibit that, correct?
Absolutely. And our real concern is just making sure that in the future, if a crew member goes on a long duration flight to Mars, for example, that when they go down to the planetary surface and need to interact with their computer-based devices, they can do so with accuracy.
Okay, and what are so much of the research we do on station has direct effects and benefits for us down here on Earth? What are some of the benefits or some of the things that we could hope to learn from this study that, you and I down here on Earth might, benefit from?
Well, we're very excited about the development of this fine motor skills test battery, and we think that it has promise to be used as a diagnostic tool or a rehabilitation tool for Earth populations who have fine motor deficits, and that would include people, for example, that have brain injuries or suffering from diseases like Parkinson's.
Okay, so not only safeguarding our astronauts and making sure they'll be able to work when they're heading off to Mars, but also potentially helping, some of us down here on Earth.
Absolutely.
Very cool. Well, again, Dr. Tina Holden, the principal investigator for fine motor skills, taking place on board the International Space Station right now with the one-year crew members, Scott Kelly, Mikhail Kornienko. Doctor, thank you so much for joining me today. We really appreciate it.
Thank you very much.